Hello and welcome back to my RC channel. I'm Andy RC and this is part 2 of my experimental iFlight based freestyle copter. Today I'm going to be flashing the latest version of KISS to the iFlight all-in-one flight controller which has been Flyduino licensed. However, this video might also help you if you have a KISS V1 board and have used non-KISS ESCs, because if you use non-KISS ESCs with a KISS based flight controller, they're closed-sourced serial-based system blocks the use of any kind of pass-through to access third-party applications such as BL-Heli or BL-Heli32. Now, for me, the only reason to use pass-through to BL-Heli through the flight controller is to change the direction of the motors, and as I mentioned in part 1, all of these motors spin anti-clockwise with this setup. So, I need a way of changing the direction, and I will be showing you how to do that, but without using pass-through. Of course you can do it the old-fashioned way and desolder two of the wires and then switch them over on the motors that need reversing, but everything is taped up here already, so that's not how I've done it. It may also help some people running the official KISS V1 boards but are wanting the latest of everything. So let's flash the latest version of KISS for the V1 board and set everything up. Now I use the word latest loosely because I don't think Flyduino has put a version of the firmware for the KISS V1 board for quite some time. However, it seems on GitHub they have been working on beta releases up to the end of last year, so that is what I'm going to be flashing and installing. But the first thing that you need to do is go to ftdichip.com and download the virtual COM port drivers. Now I'm doing this on Windows, so I have downloaded the Windows version. Then you're going to need to download Diffuse, and that just basically puts the copter into DFU mode, which stands for Device Firmware Upgrade. Now, as this flight controller is based on the KISS V1 board, then you can't upgrade the flight controller through the KISS GUI, whereas on the V2 you can, and of course they're going to be focusing on the V2 now. I always find it interesting that to get things flashed to KISS is really difficult, and some of the hardware can be tricky to get around because of the serial situation. But then once you get to the GUI, it is super simple. Anyways, to download this software, you click Get Software, but you can actually just scroll down and download that from here. Then of course we need the KISS GUI, which you also get from GitHub, and I'm going to be using the 64-bit Windows version, so that is here, but of course we've got different OSs here, and we are also going to need the latest firmware for the V1, which is currently on GitHub, and its release date was September the 5th, 2018, and it is version 1.3 RC36i beta, as you can see, and you download that from here. So the next thing that we need to do is put the copter into DFU mode or bootloader mode. Now with the early KISS V1 you had to short a jumper to put it into that mode, but this flight controller has got a button, so we can press that button and then plug the USB into the computer. So I'm going to do that now. Okay, so I'm holding down the bootloader button and I'm going to plug it into the USB of the computer. And then if I open the Diffuse software, which is here, you will see that it says STM device in DFU mode. Now, if you don't have that, then you have either not pressed the button correctly or you have a driver conflict. And I always like to use Zadig for that, which you can download. So when it doesn't say DFU mode here, it doesn't mean that it's not in DFU mode, it just means that the wrong driver is selected. So in Zadig, if we click Options and then List All Devices, what I should be able to find down here is STM32 bootloader. And then what you want to do when you see that is click Replace Driver or Update Driver. If you don't see that, then it's not in DFU mode. But if you do see it, then it is. Now, once you have clicked Replace Driver, the mistake a lot of people make at this point is they carry on and they go to diffuse, they might even reopen it and it's not there. What you have to do is you have to unplug the copter from the USB port and plug it back in, but I don't want to do that because I'm going to have to press the button again and that will be a pain. But yes, very important to unplug the copter and plug it back in. It will then recognize the new driver. Otherwise, it is just running on the previous driver which wasn't working. So we are done with that. So the next thing that I need to do is click Choose here and then locate the folder where we downloaded the KISS firmware. So that is here, and you can see it is 1.3 RC36i DFU. So I select that and press Open and it will say File Correctly Loaded. So now I click Upgrade and we'll get some errors. So it says your device is read protected, would you like to remove read protection? I click yes. Then it says your device was plugged into DFU mode, so it's impossible to make sure that this file is correct for this device. Continue, however. Yes, I think it's always said that actually, even back a couple of years ago when I was doing this, but it looks like it's upgrading, so that's a good thing. But it is taking a little bit of time. Now you can click Leave DFU mode, but I think that's always failed for me in the past. Let's see what happens, and it takes a little bit of time as well, but it always sort of gives an error. The best way to leave DFU mode is to unplug from your computer. Yeah, I thought I'd get an error. So can I close this, or is it just going to lock up? It's quite a temperamental program, this. Yeah, now let's close the program there, and then while that's doing that, I'll unplug the USB from the computer and plug it back in. And down here we have the KISS GUI, and we should get a COM port. So if I connect to it now, so we've got a warning and we have to activate the flight controller, and even though it is not a Flyduino flight controller, it is licensed by them, so we have internet, and if I press activate now, then it should work. And there we go, we are in. We have got the correct version down here. Now, as for the setup, when I did my KISS Alien, I copied Chad Noak's PIDs that he did from his Rotor Riot reverb build, and I've already tried that with this model and the motors got warm. So I've already done a line of sight flight, so the video's a little bit out of sequence, but that is the magic of video editing. You can do stuff before and after and mix them about. And I was finding that the motors were getting warm. So what you can do with KISS is there are actually presets that people have come up with, and I actually found a similar setting. I think I went down to I and I found iFlight somewhere, and it was a very similar setup to what I had got. So it was iFlight and then Jason, there we go, and XL5 lowrider and 45 amp ESCs. So I selected that one, and then I set up all of my configuration. But I've already set everything up, And another good thing about KISS is that you can save all of your settings. A bad thing about it, I guess you could say, is when you flash the latest firmware, it resets all of your settings, but you can save them and restore them. So that's what I'm going to do. So you can see there we've got KISS FC Backup HL5. If I press open there and then save, we have all of the settings already, and the settings are pretty simple. What's interesting though, I've noticed, is that they have reversed the propeller direction for props out. So actually earlier, when I had the propellers in the usual configuration, I'm actually going to have to reverse them, otherwise it's not going to fly. So you can change that setting, and that must have been something that this person did. So it's very simple, quad X, then motor output mapping as default. Receiver, I'm using S-Bus, but of course we've got all of those other options. And then we don't want anything here. I think this is a delay for the failsafe, but I just want that as 0. Then we've got the PIDs here, which seem to be much lower on the Ps, and I think that was causing the motors to heat up. You know, it's a different copter. Yeah, it's a similar weight, but different copters need different PIDs, and specifically with KISS, I think that is more so the case. It's very specific, and you have to dial the PIDs in more than you do Betaflight, which is a bit more forgiving. So then we have got the min throttle at 1070 and the max throttle at 2000, the min command at 1000 and the mid command at 1500, and ESC mode Dshot1200, that's the highest that the V1 goes. You can do 3D mode if you want, but I'm not going to. So this setup here will give the kind of air mode that you get with Betaflight. So when I arm it, then the controls will go in. It's not the idle up setting. I think to do idle up you would have this at 1000 as well, and then you'd have to do some settings in your transmitter. I haven't explored it because I don't really use it. Then for my auxiliary functions, I've got it to arm on the AUX1. I'm using an X9D, and I've got that in the high position, copying what I do in Betaflight. Then level, that is going to be angle, I've got on the AUX2, and that's in the low position, again copying what I do in Betaflight. And then buzzer, we have got on AUX3, and again in the high position, and I put that on a 3 position switch. Now Chad on his settings used the high setting for the filter, but this one is medium high, so I'm going to leave it. And these are the PIDs for when it's in level mode, so angle mode. And that's the first page, very simple. So if we go into advanced, so yeah, you can see this is the setting here that makes the props in the out direction. They call it your control direction. They should just call it props out because it's confusing. But yeah, I'm going to have to put the props on the other way around and also map the motors so that they spin in a different way. So RC deadband 2, and I think I put that in there. That is just so that when the sticker's around the center, the slight movement you get from the sub-trim not quite meeting 1500, it sort of smooths that out. And I usually use 5, but I think Chad used 2 in his settings, so I've sort of combined the 2 settings here. So serial config, we don't want to use anything advanced there. For the logger config, we want the logger disabled /OSD, and then down here VTX config, This VTX uses the IRC tramp protocol, so I've selected that, but we've got Unify in there as well. And I'm going to be running Race Band, and this is something that I really like about KISS. You can do it in Betaflight, and as far as I'm aware you have to do it in the CLI. It might have changed because I can't keep up with Betaflight because it changes every single day, but when you are not armed you can have it at 25 milliwatt, and then when you arm you can set it to the highest power. Now you have to be careful with this because I thought, oh, that is great, you can set this to 5 milliwatt, but it will only accept what your VTX is capable of doing. For example, this will go all the way up to 800, but the tramp protocol only goes up to 600. So if you go any higher with this, what will happen is you will arm and it will stay at 25 milliwatt because it doesn't recognize 606 milliwatt. So be very careful with that, but it does work, and I will overlay some video showing it working, and it's absolutely superb, I think, because if your copter is sat there and it's not armed and it's at 600 milliwatt or 400 milliwatt or whatever, I think it was showing 400 milliwatt, but I can't get to this exact frequency, so I think that is why. I've got it showing 500 milliwatt, I've even had it showing 700 milliwatt, because you can detune the meter that I was using, the power meter, and it will show a higher value, but it's fine for me, and I like this setting. And you also have to set that up in the on-screen display as well. So down here we've got buzzer emulation, so I didn't attach a buzzer, so this is using Dshot commands as a lost model alarm, and also when you lose RX connection you will get a beep as well. And I haven't fitted any LEDs, but we've got that down there, and lap timer stuff which I'm not using. So set point weight in D-term, I copied this from Chad. So I've got it set to 65. Enable adaptive filter, because that apparently is what makes KISS KISS. Now I'm not sure what these two do, but they are turned off. And then down here, advanced settings, this person has set it to medium high, whereas Chad had got it set to high, but I'm going to stick with medium high and see how we get on. Like I say, this is a learning process for me really, rather than a how-to. And with this kind of stuff, setting the filters high, especially on a F3 board, maybe could overload it, but it could also heat up the motors as well. So I'm gonna keep this to medium high, but when I did the line of sight flight I had it on high and the motors were getting warm. So if we come down here, your filter at 35 and LiPo alarm, I've got both set at 0 because I find those annoying, and this has an on-screen display so we can use that. So data output, so I've already bound this up, so I'll turn the Tyrannus on, and the receiver actually powers up when it's plugged into the USB, which is nice. So you can see I've got all of my values working there, and then my mode switches. So that's the aux 3 that I've got for the buzzer, that's the aux 1 for the arming, and then aux 2 for our acro and level, so it's in level mode there. So that is low, medium and high essentially. So you don't have the sliders like Betaflight, but you've still got good control over it. Now this is the RSSI value, and it lost it there because the transmitter's too close to the receiver. But one thing I noticed with the RSSI firmware for the XM Plus is that it jumps around a lot. Can you see? And if you get too close, then it will get lost. You see, it's dropping out there, which is weird because it's not a telemetry receiver and I've bound it in non-telemetry mode, but it still seems to get affected. Now you need to remember this number. I think I measured it at around about 1800 as being sort of the stable number when you hold it. You can see it's just sort of hovering there. Now it's important to record this number because we're going to want to put that in our on-screen display to calibrate the RSSI. And in the same way, if we turn off the transmitter, what you'll get is a reading there, 1100. The thing I noticed though, and it probably won't do it just because we are on camera, but when it comes back, when I turn it off again, yeah, look at that, it sits in a different place every time. I'm not sure the RSSI can be trusted too much on the XM Plus receivers, but there you go. So I also at this point put the copter on a flat surface, but because it's got that standoff at the front, I used my scales actually, and that made it completely flat. So I put it on a flat surface, horizontal should I say. There are some people out there who are so nitpicky that they don't understand that when I say flat, and there's a picture of a flat copter, that it means horizontal. By the way, if I pick it up, you'll see it moving around there. So yeah, I think that is everything on that page. And then if we go into rates, I think that is just a copy of what we have got in the configuration tab. So 1.2, I think it just shows you as a picture, and if you move it around, then yeah, it will sort of show you the expo that it is applying. So I think that's the point of that there, and you can also change and save some of the settings. So I think that's the point of that. TPA, so this is the custom TPA that Chad used, so again I just copied that. And then we want to talk about the ESCs. Now at the moment the battery isn't plugged in, so if we click ESC flasher, you get this warning and it says I know what I'm doing, and we have no options to reverse the motors. However, before I go any further, I want to make it clear that you need to have the props off when you are plugging in the battery, because if something goes wrong and the motors spin up and the props are on, you could really hurt yourself, and it'd be quite difficult actually to stop them as well. So yes, make sure that the props are off. I cannot stress that at this point, and we'll put the props on again once we have finished the setup and also tested the failsafe. If I disconnect this and then plug in a battery, so I got one here, and the copter's still plugged into the USB. If I press connect and then go to the ESC flasher, this time you can see I can reverse the direction. Now because KISS uses a different motor mapping, it can get quite confusing, and it's even more confusing because in this situation it has the props going out. So when I first armed this guy, everything went anti-clockwise, so I reversed this one and this one, but because we are going props out, I need to reverse this one and this one, so that's PWM2 and PWM4. So if we go back to the ESC flasher, you would click 2 and 4 and then save. And once you have pressed save, what you want to do is disconnect from this and then disconnect your battery, plug your battery back in, and then connect. And at this point I should be able to arm the copter, if it will let me. Let me just go to the data output. Let's see. Yeah, there we go. So I need to make sure that it had got a signal, so I should be able to arm now. And let's just stick it in acro mode. So yeah, you can see there as well, it tells you what mode. So level mode, acro mode, and that's the beeper with the aux 3, and then I should be able to arm it, and then with my fingers I can just see that, yeah, it's running props out. And you can actually test them individually as well. So it's making that noise because it's losing the RX. So yeah, if I put this too close to the copter, that's the transmitter, and it's not doing it now, isn't that just typical? But yeah, if you're too close to the receiver, you'll get a failsafe, but that's what that noise was. Anyways, in one of these you can do a test of the motor. So can you see it says there, test, and again you get a warning, so you have to have the props off when you do this. It's beeping again because it's lost its signal. So you have to click I know what I'm doing and then enable motor test, and what you can do is you can just select a motor, and you don't even need to arm it. You can just lift up the throttle and just that motor spins, and same with the other one. So rather than Betaflight, you have the sliders. I'm actually doing this with the transmitter, and of course you can select all of them and then lift up the throttle, and it bypasses the PID loop just like Betaflight. So all it does is throttle, and you can see that they are all moving in unison there. So the last thing to do is to check that the failsafe is working. Now I know that it is working sort of, because the motors are making a noise when it's losing signal, but I want to make sure that all of the motors arm and disarm when I turn the transmitter off. So I'm using an X9D here, and you need to set it to no pulses. So I'm going to arm it, and then I'm going to turn off the transmitter, and they should stop, and that noise you are hearing is the warning signal, or beacon should I say, to say, I'm lost, come get me. Now before I end this part 2 video of the series, there is a subject that I want to touch on which I mentioned in part 1, and that is this controller board that you are given when you buy the iFlight KISS all-in-one flight controller. It has got 2 functions, so your USB cable connects into here, and then this goes into your computer, and then this has a wire, so it's a JST wire, and that goes off into this connector, and it's for configuring the on-screen display, so that can be either multi-wii on-screen display or KISS on-screen display, and I've chosen KISS on-screen display because it's brilliant, and that's what part 3 is going to be about. But it also has another wire which has got more connections on it, and it's a JST connector again, and that is to connect to the underside of the flight controller, and then you are given a jumper, so you fit that over the top, and apparently you can get BL Hali pass-through working. Now I couldn't get it to work, as I mentioned in part 1, and it doesn't really matter because all I use BL Hali S or BL Hali 32 suite for is to change the motor direction, and in this video I've managed to do that without having to connect to BL Hali suite. However, iFlight tell me that this should work, and also a chap on part 1 said that there was no need to unsolder the wire, so my suggestion was that you'd need to desolder the telemetry wire and also the signal wire, and you'd have to maybe make up a connector that would connect to this board. And I assumed that because this is the diagram that they have given, and the diagram even suggests that you don't flash the ESCs and set them up through this cable here. I mean, it comes with the cable, but they are suggesting here that you connect them up separately. Anyways, iFlight say that it should work, and I can't get it to work, so I'll show you what is happening. So, if I load up Dshot1200 this is the latest version, but I've also tried the version that is in the instructions. Anyways, so I don't have a battery plugged into the copter at the moment, but I do have this connected up here. So this one is going to the underneath of the flight controller, and we have got the boot shorted here. And the COM port does show up. It does show up there. And if I plug in a battery, and of course you need to make sure that you have the props off, so I'm going to do that now. So that's the battery going in, and we don't get the last tone, which is correct. And if I go down here, let me get the mouse and press connect, then we get the beeps, and it seems like everything is fine. But if I press check, it recognizes ESCs, but we don't have anything here. And if I press OK, I get this error. So if I press OK, I can't do anything down here. I can't change any directions or anything like that. The only thing I can do is disconnect. And I do have BL-Halley32 clean flight / beta flight selected, and it's not working. One thing I noticed though is the naming of the COM port. You see Silicon Labs CP210, and I thought, I wonder if there's a driver conflict, because there is actually a way that you can get around the whole KISS serial problem. You see, there is a bootloader button on the flight controller. So what you can do is you can get another USB cable, and you can press the bootloader button, and then that will put it into bootloader mode. And by doing that, the serial-based system that they have when the flight controller boots up normally is no longer getting blocked. So I tried that, and I got the same error. So it could possibly be a driver issue. The reason that I think that, I've got another copter that will run BL-Halley32, and again I've got the props off. So if I go down to BL-Halley32, this time the COM port says STM Microelectronics Virtual COM port. And as you will see, when I connect with this copter, I don't get any tones. That last tone usually means that it's recognized the signal, so something's not right there. And then when I press check with this copter, it recognizes all of the ESCs. So if I press OK and then disconnect, that one is working. So it could be a driver confliction. My only issue with that is if I start messing around with the drivers now to get it to match, then the Xloader program, which flashes the KISS on-screen display firmware, is working, and I don't want to mess that up. So I may come back to it at a certain point and see if I can try and get it working. Also, there are other variables, like I've updated KISS to the latest version. That may have implications, but as you can see, it is not working. So, until part 3, I will see you there, and as always, thanks so much for watching. Please continue to subscribe. Cheers.